Take a look at these: milk, butter, gelatin, mayonnaise, muddy water, and colored glass. We use them in our day-to-day life. But have you ever wondered about the chemistry hidden in them? These substances are known as colloids in chemistry. Colloids play an important role in interface science and in the fields of energy, food, mineral processing, pharmaceuticals, and environment. Colloids are one of the three major types of mixtures, the other two being solutions and suspensions. The three kinds of mixtures are distinguished by the size of the constituent particles. You already know that solutions are homogeneous systems in which the diameter of the solute is less than 10 to the power minus 9 meters. These particles are not visible to the naked eye. Common salt in water is an example of a true solution. On the other hand, a suspension is a heterogeneous system. The particle size of the molecules in a suspension is more than 10 to the power minus 6 meters. These particles can be seen with the naked eye. Sand in water is an example of a suspension. Colloids are mixtures whose particles are larger than the particles of a solution, but smaller than the particles of a suspension. The suspended particles in a colloid are small enough to settle down due to gravity. Thus, colloids represent an important and a large group of systems intermediate between solutions and suspensions. Therefore, a colloid is a heterogeneous solution in which the particle size ranges from 10 to the power minus 9 to 10 to the power minus 6 meters. These particles are not visible to the naked eye, but can be seen under a microscope. Milk, blood, honey, and starch solution are all colloids. Colloids are also called colloidal dispersions because the colloidal particles are dispersed throughout the mixture. For a colloidal solution, we use the terms dispersed phase and dispersion medium. The phase that is scattered or present in the form of colloidal particles is called the dispersed phase, and the medium in which the colloidal particles are dispersed is called the dispersion medium. For example, in a starch solution, starch represents the dispersed phase, while water represents the dispersion medium. Colloids can be classified on the basis of the physical state of the dispersed phase and the dispersion medium, the nature of interaction between the dispersed phase and dispersion medium, the type of particles of the dispersed phase. Let us first discuss the classification based on the physical state of the dispersed phase and the dispersion medium. Depending upon the physical state of the dispersed phase and dispersion medium, 8 types of colloidal systems are possible. Dispersion of a solid, in a solid, liquid, or gas dispersion mediums result in the formation of a solid sol. fluid sol, and an aerosol respectively. Colored glass and gemstones are examples of solid sols. Paint, muddy water, and cell fluids are fluid sols. Fluid sols are mostly referred to as sols. Examples of aerosols are smoke and dust. Dispersion of a liquid in a solid, liquid, or gas dispersion mediums result in the formation of a gel, emulsion, and an aerosol respectively. Examples of gels are cheese, butter, and jellies. Milk, hair cream, and certain medicines are examples of emulsions. Fog, cloud, mist, and insecticide sprays are examples of aerosols. Dispersion of a gas in a solid or a liquid dispersion medium results in the formation of solid sol and foam respectively. Examples of a solid sol with gas molecules are pumice stone and foam rubber. While soap lather, whipped cream, shaving foam, and froth are examples of foam. It is important to note that the colloidal system of a gas into some other gas is not possible because gases always form a homogeneous solution. Since colloidal systems are heterogeneous, they cannot be obtained by dispersing a gas into another. Depending upon the nature of the dispersion media, sols are given different names. For example, if the dispersion medium is water, then the sol is called as aquasol or hydrosol. And when the dispersion medium is alcohol, it is called an alkosol. Another way of classification is based on the nature of the interaction between the dispersed phase and the dispersion medium. Depending upon the affinity of the dispersed phase for the dispersion medium, colloidal systems can be classified into two categories: lyophilic and lyophobic sols. Let us first discuss lyophilic sols. The word lyophilic means liquid-loving or solvent-loving. When substances like starch, gum, and gelatin are mixed with a suitable liquid, that is, a dispersion medium, they readily form colloidal solutions. Such colloidal solutions are called lyophilic colloids. When water is the dispersion medium, they are called hydrophilic colloids. Lyophilic sols are quite stable and cannot be easily precipitated. An important characteristic of lyophilic colloids is their reversible nature. That is, if the dispersed phase is separated from the dispersion medium, for example, by evaporation, then the sol state can be achieved again by simply mixing with the dispersion medium. Let us now discuss the second category of colloids: lyophobic colloids. The word lyophobic means liquid-hating. Lyophobic colloids cannot be formed by spontaneous dispersion in the medium, but can be prepared only by special methods. Arsenic sulfide, ferric hydroxide, gold, and other metals form lyophobic colloids. These metals are sparingly soluble, and thus their molecules do not pass readily into the colloidal state. Lyophobic colloids are also known as irreversible colloids because the residue obtained by evaporating the dispersion medium cannot be converted back into a sol through ordinary means. Lyophobic colloids are readily precipitated on adding a small amount of electrolyte by heating or by shaking vigorously, and hence are not stable. Lyophobic sols need a stabilizing agent if they are to be kept for longer times.